Hello everyone, welcome back to another of AMC 8 preparation course videos. Today we're going to be looking at our little bit of a scale here. So let's read the question. There are 9 apparently identical balls except that one is heavier than the other. 8. What is the smallest number of balanced scale weightings required to ensure identification of the odd ball? Let's try it out. We have 9. Since we have 9, which I'm going to draw here, we can split them into 3 groups as shown. Right? Now this is clearly not done well. If I split them into 3 groups as shown, I can weigh them individually. Right? If I weigh them, hopefully this is a nice visual. Let's assume what will happen. Right? Now, if one side is heavier and leans down, then that means the odd ball is there. If another side leans down, then it is there, right? The side that leans down has the odd ball. I know, that was some fun, me rotating the scale too much. Of course, if this side is heavier, then yeah, let's go back. If they're both the same, then the other set, which is shown here, will have the heavier ball. So now, normal thing to do, let's remove these, put them back. So now assume this one's the heavy one. Any of them could be, but we will definitely know after one weighing. So one weighing done so far in red. Now, looking at these balls here, the 3, we can split them individually into 3. So I'm going to draw them again. 1, 2, and 3. Now they're individual. We weigh 2 of them. Now we might immediately know, because if one is heavier, we then immediately do actually know. But otherwise, it's the other one. But if it's the same, what will happen? Well, clearly we need one more weighing. Or do we? No, we don't. Because no matter if they're the same or not, we will know which one is heavier. If they're the same, then of course it's this one. So in total, we needed 2 weighings to figure that out. And that is the answer. We need at least, or the smallest number of 2 weighings to find out the answer. Thanks.